Hey TechKnowStuds! When we're using quantitative risk analysis, one thing that we could be using is a single loss expectancy, or SLE, and exposure factor, or EF. So in this lesson, let's jump into those two. When we're dealing with risk and analyzing risk, what we want to know is that we want to know how much this is going to cost us every single year. And we call that an annualized loss expectancy. And there's an equation for that. And as part of that equation is the single loss expectancy. So let's jump into single loss expectancy and how to calculate that. So let's break this apart of what a single loss expectancy is. So first of all, there's the expectancy. That's what we expect. That is what we're going to estimate. That is going to be what we are thinking is going to happen. The loss is, what is it, the monetary value that we're going to lose, that we're not going to have any longer once this happens. And a single occurrence, so just one occurrence of this. So in this example, like right here, is just when one person gets scammed, what is the expected loss of that? Single loss expectancy is just an equation, what we have right here. So to calculate single loss expectancy, we would take the asset value and we'd multiply it by the exposure factor. The asset value in this example right here is 200,000. So we have some sort of value of the asset itself, so 200,000. Now, if it were to get stolen, then that would be 100% or 1, or the exposure factor in this case is 50%. So we're estimating that we're going to lose half the value of that asset. Well, that's the single loss expectancy. Asset value, where I cover more in depth in another video, is just what is the monetary value of anything that you have. The exposure factor is just how much we would expect to lose if the risk happened. So in this case right here, maybe we have a monetary amount and maybe we have $100 and we lose 50 of those dollars, and so now we have $50. So the exposure factor in that case is 0.5. And we can calculate whatever we have is just whatever the reduction of that asset value is going to be that exposure factor. Now, if you're studying for a certification or talking to others, this is the going explanation of how to calculate single loss expectancy. But I feel like this is a terrible equation. It really is not applicable in a lot of situations, or maybe even most situations. And I don't like either side of this equation. The asset value right here seems like a terrible measurement to me. Number one is because a lot of times we're not dealing with a specific asset. Maybe it's not necessarily a let's say like a server that got stolen, but maybe it's the data that was stolen from the server. And we actually still have the data. We haven't lost that data, so the asset is still there, but now we have to clean it up because customers' data was stolen. And there's a lot that goes into cleaning all of that up. So that is, using asset value really doesn't make any sense to me. Even if it was a specific asset that was stolen or something happened to it, we still have to look at redeploying or fixing it or whatever goes into fixing whatever issue it was. Not to mention, if it had data on it, in this case, servers were stolen, then there's a lot of the other notifications and legal fees and reputation loss and revenue that we have to still calculate for. We still have to understand that impact. And so really, this side of the equation, the asset value, is a terrible thing to use for a single loss expectancy. And on the other side of this, we have the exposure factor. And I really can't stand this either, because now let's take a little different scenario. Let's say this breaks right here and one of these servers breaks, and we call in a repair person to fix this. And maybe the repair person costs us $2,000 to fix whatever was broken on that server. Well, how are we going to calculate the exposure factor? Well, what we're going to do is we're going to take the cost of this server. So maybe the server costs $20,000, and we're going to divide how much the repair is by how much the server costs, and then the exposure factor here is going to be 0.10. It's 10% essentially of the cost of the server. And then we times that by the asset value. So the asset value is $20,000. So you multiply that together, and the single loss expectancy for this particular thing is $2,000. Well, what that is the cost of the repair. That's the single loss expectancy that took to repair the servers. So this equation really just seems like a really goofy equation to me. But for some reason, this is the standard equation that we use to calculate single loss expectancy.